All right, guys, these are the notes for section 3.4a. We are again looking at graphing. More specifically, this section is about slope. And slope is known as the slant or the steepness of a line. Okay, and on that first graph I've got there, I've got the example of a slope. And what that example is a positive slope. And to think about a positive slope, it's like going up a mountain. You are increasing your elevation, so that is positive. Okay? So mountains have positive slopes. And you read a graph left to right, just like you would be reading a book. So as if the graph is going up as you go from the left-hand point to the right-hand point, that means it is positive. Now, if you look at the other one, that is a negative slope. Because if you start at, if you start at the left-hand side and go to the right-hand side, you are going down a hill. So that makes it a negative slope. Okay, we'll talk a little bit more about determining. You will also be able to visually, not only will you be able to look at this and tell me it's a positive or negative slope, but you will also be able to look at equations of lines and tell me if it's a positive slope or a negative slope. Then we've got a couple more. We've got this horizontal line here. And a horizontal line has zero slope. Okay? So the slope is equal to 0. In this example here, this would be like y equals 3. That's perfectly acceptable. On the second example over here, you have a vertical line. Okay? It's going up and down. A vertical line has undefined slope. All right? So if you get something that has a vertical line and it asks for the slope, you're going to say it's undefined. And this is an example of x equals 4. All right? You're also going to be asked to determine slope. Okay? We call slope, we use the variable m. M is equal to the change in y all over the change in x. So, oops. Oh well. So if you have that, really what that means is you will see the notation, the change in y over the change in x. Okay, those little triangle signs that are called deltas, and they mean the change in. Or you might see it, really what you're going to need to know is this equation. y2 minus y1 all over x2 minus x1. Okay, so you're going to get two sets of points. One's going to, and each set of point will have an x and a y value. So you need to make sure that the x1 is with the y1 and the x2 is with y2. You just have to make sure that the 2's and the 1's stay together with their points. But you have to have 2 points in order to be able to find the slope using this equation here. So let's do an example. All right, so you're going to be asked to find the slope, find m from these 2 points. So I want to see this. M is equal to y2 minus y1 over x2 minus x1. All right. Which one's y1? Which one's y2? What's x2? What's x1? And I would take on your piece of paper above it, right, this is x1, y1, and this is x2, y2 for the 9, okay? Doesn't matter which one you pick is x1, y1, and x2, y2. No, you just have to make sure the 2's stay together. So now I can come in and replace. y2 with -9 minus 1 all over -5 minus -7. Okay, so -9 minus 1 gives me -10 all over, well, that's a double negative, so that makes it a plus, all over 2. Now, how many times does 2 go into 10? 5 times, and the number stays negative. Okay, so my slope is equal to 5. Really, I would have liked to been able to put slope in as 5 over 1, but the computer will not accept this version, so you need to simplify it. I would accept this on the test, but the homework will not. So just be aware. All right, so find the slope of -2, 6, and 6, -1. Once again, here, I'm going to start off by writing the equation. M is equal to y2 minus y1 all over x2 minus x1. Now let's see, what's my y2, y1? Let's go up here, x1, oops, y1, x2, y2. All right, so now I can place them in. So that gives me -1 minus 6 all over 6 minus -2. That makes a plus. So 1 minus 6 is -7, and 6 plus 2 is 8. So therefore, my slope is -7/8. Not too bad. All right, again, find the slope from the points 3, 7, and -2, 7. Okay, first thing first, write the equation y2 minus y1 all over x2 minus x1. This is x1, y1, x2, y2. All right, my y2 is 7 minus 7 all over -2 minus 3. 7 minus 7 is 0 over -5, which happens to be 0. So my slope is 0. Perfectly good, perfectly acceptable. You can have 0 slope. That's what we call that horizontal line. It's like when you go skiing, you go downhill skiing, you hate when you have no slope because you're just standing there on your skis or having to push with your arms. It's not very much fun. All right, here we go. Another slope problem. Start off with m is equal to y2 minus y1 over x2 minus x1. So you have x1, y1, x2, y2. All right, so then I'll have 8 minus 4 over, oops, foolish person, got that wrong. Okay, so you have 8 minus -5, double negative, we'll make it a plus. Then you will have 4 minus 4. So now I have 13 over 0. This 0, you can never ever have a 0 in the denominator. Rules of fractions say no zeros in the denominator. Therefore, oh gosh, where'd it go? Therefore, this means the slope is undefined. All right, so you can answer that the slope is undefined. That's a great answer, but that's only if the zero's in the denominator, in the bottom. If the zero's in the top, otherwise the numerator, the slope would then be 0. So just be careful. Check between this one and this one. Pay close attention.